Okay, let's look at the example 1. The question is, find dimension that will minimize surface area. The shape given is cylinder and the volume is 800 centimeter cube. As we know, the volume for cylinder is pi r square h. So we substitute the volume is 800. So 800 equal to pi r square h. So h equal to 800 over pi r square. The surface area the surface area, the formula is 2 pi r square plus 2 pi r h. Formula for surface area is 2 pi r square plus 2 pi r h, which r is here and h is here. So the 2 pi r square is 2 circle over here, and 2 pi r h is the rectangle inside the cylinder. We have h here over here, so we can substitute the value of h into the h here, which gives us 2 pi r square plus 2 pi r. Substitute the value of h, 800 over pi r square. We have pi r here and pi r square here, so we can simplify like here. The next one is proceed to 2 pi r square plus 2 800 over r. So just simplify 2 pi r square plus 1600 over r. Put r up here, so 2 pi r square plus 1600 r negative 1. To find the minimum value, we have to differentiate the value of area. So area respect to radius with which is dA over dr. So we get 4 pi r minus 1600 r negative 2. As we know, to find the minimum value, dA over dr is equal to 0. So 4 pi r minus 1600 r negative 2 equal to 0. So this question gives us over r squared equal to 4 pi r. So we can find the value of r over here. We multiple all the question with r squared, which give us this one. So we just continue to find the value of r. Over 4 pi. So the value of r is the cube root of 1600 over 4 pi, which gives us the value of r 5.03. So now we obtain the value of r, so we can find the value of h. We just substitute the value of h into the first equation we obtain when we make h as the subject. So we substitute the r we find over here, so we get the value of h. Like here, the h from the first equation is 800 over pi r squared. So substitute the r here into here, we get 800 over pi 0.03 power of 2. We get the answer 10.06. So that's it. The value we get the value of the r and h, which is the dimension that will minimize the surface area of the cylinder. Thank you. Proceed to example 2. The question is, a rectangular frame is to be made from a piece of wire 120 cm long. So this is the rectangular and the length is x cm the width is y cm. A. If the length is x cm, express the width in terms of x. So, the formula is 2x plus 2y equal to 120 cm. Because 2x plus 2y is for the perimeter. Then, we express y in terms of x. We simplify the formula, the equation, and we get x plus y equal to 60. Then, y equal to 60 minus x. For question B, find its area in terms of x. As we know, the area for rectangle is A equal to x, y, which is x the length and y the width. So, we substitute the y into this equation, which is our y is equal to 60 minus x. Then, we substitute into a area equation. 60 minus x. So, we get the area formula is 60x minus x squared. For question C, find x for minimum area. As we know, our area equation is 60x minus x squared. And we differentiate the area formula, then we get dA respect to x, which is 60 minus 2x. To find maximum area, dA over dx equal to 0. Then, we substitute as 60 minus 2x equal to 0, and we can find the value of x, which is and we get the value of x, which is 30. So, the x we get is x equal to 30. So, the x we get is 30. Then, from the previous equation, dA over dx, we get 60 minus 2x. Then, to find whether it is the maximum or minimum value, we do a second derivative test. And we get, for the second derivative, is d squared a over dx equal to negative 2. So negative 2 is less than 0, and the value of x equal to 30 is maximum. Maximum value because the value for second derivative is negative. Find the maximum area. The equation for area is 60x minus x squared. Then, our x maximum value is 30. Then, we substitute the x value into this area equation, and we get 60 times 30 minus 30 squared, and the maximum area is 900 centimeter square. Thank you.
Okay, today we're gonna know the concavity and points of inflection. Okay, for the first example, we must find the point of inflection of function of x equals to x cubed minus 6x squared minus 3x plus 1. And then we're gonna know where is the function of x concave up and concave down. Okay, first we take the first function formula equation, which is x cubed minus 6x squared minus 3x plus 1. We use first derivative, which is we differentiate the function, which will be 3x cubed minus 12x minus 3, and then we apply second derivative, which will be differentiate another time, and it will be 6x minus 12. Okay, from the second derivative, we will get the critical value. We must equate the second derivative to be 0. 6x minus 12 equal to 0, and then we get the critical value, which is 2. After that, from the second derivative, we get the critical value x equals to 2, and then we use the number line. We choose any number from negative infinity until 2, and we choose another from the right side, positive infinity until 2. So at here I will choose 0 and 3. Okay, based on the number line, we choose 0 and 3. Okay, for the second derivative, we substitute 0 into the equation, and we will get negative 12, which is lesser than 0. And from the second derivative also, we substitute 3, and we will get 6, which is greater than 0. Okay, we can conclude that the second derivative, which is smaller than 0 on negative infinity until 2, and the second derivative is greater than 0 on 2 until positive infinity. Okay, so that we can conclude that fx is concave up on 2 until positive infinity, and fx is concave down on negative infinity until 2.